Thank you so much for tuning in to the Psychology Is podcast. I'm Nick Fortino, and I have the great pleasure today of talking to Dr. Kent Berridge, who can probably explain to me exactly what's happening in my brain as I feel this great pleasure to speak with you, as how the brain generates pleasure is one of your research interests. I'm just so impressed and inspired by the career that you are having in the field of neuroscience and psychology. And to give listeners perspective here, Dr. Berridge is currently a professor at the University of Michigan at Ann Arbor and has been one of the most productive contributors to the field of neuroscience and psychology since the early 80s. And I think it's, some listeners might be aware of something called the H index, which is a way to quantify the productivity and impact of a scholar and a scholar's research. And for perspective, if you have an H index of about 60, that's considered to be remarkable. 40 is considered to be very good. And Dr. Berridge has an H index of 108 at the time we're recording this in May of 2021. So that just, for the people who like to quantify impact, that gives some perspective. So there's no way we could exhaust your expertise here in this one conversation, but I'd love to really pick your brain about some of the things you've studied so thoroughly, including addiction and what causes that and what's happening in the brain, and your theory of incentive salience. And also, one of the really interesting questions I have that we'll get into is how the brain codes for affective valence. And if people aren't sure exactly what that means, and Dr. Berridge can explain it better than me, but I'll just say it's essentially whether you like a feeling that you're having, whether it's pleasant or unpleasant. So questions around that, questions around emotions and how they relate to consciousness. Those are the three big topics I'm hoping to cover. But let me just hear your voice first. How
Sure.
are you?
Thank you, Nick. It's great to be here with you today. I'm very well, and I have to say, my own experience of a career in science has been sort of a series of stumbling forward with surprises, and we ask questions. There are questions we'd like to ask, questions that we're interested in, and there are questions that we can ask. And sometimes they meet in the middle. Often they don't quite meet, so it's sort of trying to ask the questions we can and hoping to find an answer of interest, sometimes finding answers that disappoint us in a way, but then there's a silver lining often, and we stumble forward.
Which really, captures the spirit of scientific endeavor, is accepting whatever the evidence of a very well-designed study is, even if it's disappointing, and just going from there. And then, like you said, maybe there's silver lining in it, or that the answer is more interesting than we could have ever conceived. So that's sweet. And speaking of, your reflection on your career, I did want to start by asking a somewhat personal question, which is, when did you know that this is what you wanted to do for a living?
I would say it was in my first semester at college at the University of California, Davis, as an undergraduate in a psychology introductory course that at Davis in those days happened to begin with a biological psychology segment. That was the first term. And I had signed up for it not knowing anything about psychology, not knowing that it was possible to ask questions about what does the brain do psychologically, and how can we ask it in both humans and animals and try to connect the answers. But in that course, in that first semester, I realized there were people at universities actually doing the sort of thing that fascinated me most. And I think in that first semester, I knew then that that's what I wanted to do. Not exactly which direction to go within it, but something to do with psychology, and neuroscience didn't really exist as a term, but psychology and biology, brains and evolution and minds, try to connect them.
Now that you are well along the way in your career, you've been at it for 40 years plus. Um, do you still feel a sense of passion and inspiration?
Well, yes, I do. The passion and inspiration today comes really from the fantastic PhD students and postdocs that are in my lab and here at the university, and that I get a chance to interact with. They're the ones who actually now do the research. There was a time when I did the research experiments myself with my hands, and that time is been gone for quite a while now. But they do it, and we continue to find things that surprise us and that excite us. So it's still a good time.
Mm. And before we start zooming in on those questions I raised already, one thing I want to ask you is, what is your sense? So I'll just say this, that there's the question of what do we know about the brain? And there's the question of how do we know anything about the brain? What are our means to developing our understanding of the brain? So, of course, there's different ways, and one of which, of course, is with brain scan technology. And so my question is, how advanced do you think we really are technologically in our ability to peer into the brain and see what's happening in real time? And what do you envision for the relatively near future as far as what will become possible technologically?
Well, the technology improves all the time, and it is astounding what can be done. If I think back 40 years ago when I started in the field, there was no such thing as brain imaging. There was EEG, electrical waves, but to think that you could actually see the structure and activity of brain systems, that is a mind-blowing advance. Now, I don't actually do neuroimaging scans in people. My research is mostly with brain manipulations, painless and ethical, I think, but brain manipulations in rodent studies, rats mostly, to turn on and off brain systems. If one's looking at brain scans in humans or in brain measures of activity in animals, one's seeing a neural correlate to the psychological event that's happening at the moment. Perception, emotion, the movement, the neural activation that accompanies that. And that's a correlate. And it might be a cause of that particular perception or memory or whatever, or it might be a consequence of the perception and memory causing something else. We don't know. With brain correlates, they're correlates. We don't know what they're causing. With brain manipulation studies, the essence of it, the goal is to try to understand causation, to turn a system on to excite the psychological process, or to suppress the system to reduce the psychological process, and try to parse the causation in that way. That's why we do the experiments. But technology aside, if I can add one more thing, it always seems to me, whatever technology we have, the universe is willing to whisper new truths to us. If we are able to watch and listen and detect what it's whispering. The technology is a tool, but no technology guarantees an insight into a psychological process or a brain process. It's how it's used, it's what we're willing to see. And even with very primitive technology, it's possible to gain some insights. The improvements potentially give us great advantages, but still they're just tools. It's going to hinge really on the mind of the perceiver, and in the right hands, almost any tool can be fruitful.
Well, here's an unplanned question in response to some of what you just said. My sense is that some people are willing to embrace the idea that neurological activity is a correlate to psychological activity. It seems to me that some people are readier to get on board with that than others are, and others who might be a little bit more based in a materialistic point of view would much rather say that if we're finding this neurological activity, it is always the cause, because mental activity is a byproduct of brain activity, and therefore it must originate in the brain. So I guess my question is essentially about your kind of fundamental position on inner subjective mental activity and its sort of ontology, its reality, and its relationship to the brain.
Right. Well, reductionism was a really dominant theme in the 1960s and 70s, and there are still a lot of strong reductionists today who would say that psychological activity can be reduced entirely into brain activity. Not only that's being caused by brain activity, but it can be reduced and best understood as just brain activity. I'm not a reductionist in that sense. I've never been, as I say, I got into this field through psychology. And if I've had any success at all, it's been by essentially trusting that psychological processes are real, that we have to understand the psychology. My goal in all of my research, of course, is to understand brain functions, what in the brain does what, but it's really about understanding what in the brain does what psychologically.
Mm-hmm.
Because we come with pre-existing theories about the psychology of situations, the psychology of reward, the psychology of addiction, the psychology of motivation. And in my experience, many of these pre-existing notions are wrong. There is an actual psychology to these processes, but sometimes the brain experiments tell us that it's different from what we had thought. We could talk about specific examples if you like. So it's really the whole liking versus wanting distinction that we've come upon. That's a psychological distinction that could be mapped onto the brain, but the essence of it is psychological, and the implications are powerful if it's true.
Mm-hmm.
But it's a psychological distinction. So I believe psychological processes have to be understood on their own as psychological processes. If we just try to look into the brain without them, we fail to make much progress. But the brain can be a tool, a way, an avenue into these insights.
Mm. And like you said, the implications of this being true are kind of far reaching, because to me, it changes the way I would think about everything in terms of like human volition even, and the capacity for someone to, in a way, from a sort of top-down way, from an executive function type of way, foster changes in their neural patterns. And I'm curious to know, like, what your thoughts on that. So perhaps we can begin to talk about addiction, because that's how I'm thinking a bit of it right now. So I'm not sure exactly where to start, because this is a huge topic. But the question that I'm getting at is, given this possibility that psychological processes are real, and that perhaps, you didn't say this, but perhaps they can even influence neurological activity, and perhaps the causal arrows point in both directions. But my question is it possible for a person to begin to taper down their addiction or completely grow out of it in this willful, psychologically led way?
Well, I absolutely do believe that there is a top-down causation as well as a bottom-up. It does go in both directions.
Mm.
And regarding addiction, it is common really for people who use drugs heavily in their late teens and 20s to give up the drugs by their 30s or 40s. That's very, very common. People, for example, who argue against the notion that addiction is a brain disease will often bring this up, that many people just grow out of drug use. But not everybody does. And it may be that the real essence of compulsive addiction is a longer lasting kind of thing. Psychologically, people still can escape from drug use, even if they have this compulsive addiction. It's not easy. There aren't magic bullets, but there are approaches that help a number of people. And when they do, it's through psychological 12-step programs, or through psychological mindfulness and cognitive therapy programs and other kinds of programs. It isn't necessarily a cure. This person may always struggle and may always require effort. But it happens. There are many success stories.
So maybe you can explain to us the incentive, salience, understanding of addiction.
Sure. the incentive sensitization notion basically is that some individuals, that liking and wanting in the brain can separate, and that some individuals, their wanting systems are susceptible to drug-induced sensitization, which is sort of a elevating the reactivity of their wanting system, intensifying the wants and focusing on it. To give you a sense of where this came from, if we think, back in my early science career, it tells something about the reductionism theme, and it also says something about impact in science. You mentioned in the beginning that they have a high ACE score. In the last 20 years, it's true, there's been some interest in what we do. But I'd say the first 20 years of my 40-year career, there was very little interest by my colleagues in what we did. And in fact, many of my colleagues would have said that what we were doing was a little bit wrong-headed because we weren't reductionist enough. The whole incentive sensitization theory grew out of original experiments on brain dopamine systems, mesolimbic dopamine systems, which are famous in reward and were famous even 40 years ago. They were just becoming famous. And the essence of the notion was that dopamine systems were reward. They were reinforcement. You could use several words. You could say pleasure, you could say reward, you could say reinforcement, but whatever word you used, you were talking about the dopamine system. And that meant the dopamine system was liking, it was wanting, it was everything for reward. When you pose the issue this way, then there's all kinds of legitimate science questions you can ask. You can say, which dopamine receptors are mediating the reward? Which dopamine neurons are mediating it? Are they all or some doing it? But you wouldn't really ask the question, what's the nature of reward? That's what dopamine systems are doing. You've basically answered it already by assigning it to the brain system. We stumbled into it by asking, well, let's probe a few of the psychological features of reward, such as the liking features, the immediate pleasure hedonic impact, and the impact of that on the brain at the moment that that reward is received. The dopamine hypothesis at that time, it was most famous as what was called the hedonia pleasure hypothesis. Sometimes it was called the anhedonia hypothesis because of the experiments that got to this hypothesis. Most of the experiments, the best champion in science was Roy Wise at the time. And most of his experiments would be to take rats and to give them drugs that would suppress their dopamine systems, block the dopamine receptors partially. And what he'd always find, if he gave the rats food rewards like sweet sugars, or drug rewards like cocaine, or brain stimulation electrode rewards, or sexual or social rewards, the answer was always pretty much the same. The first time he gave the blockade, the rats would still eagerly seek out the reward. But then once they got it, they seemed a little bit disappointed the next time they pursued. They pursued slower and slower. They consumed less and less. It was though, he said, that the pleasure had drained out of the reward. So they still wanted it, but when they got it, there was no pleasure in it. This was anhedonia, so the lack of pleasure, anhedonia, the word means. So the hypothesis was dopamine blockade drained the pleasure out of the reward. And if you drain the pleasure, then gradually you drain the motivation, the wanting for that.
Okay.
So most of the experiments were sort of appetitive seeking experiments. The rats would run down a runway, or they press a lever, or they consume a certain amount. They're all really asking the rat, how much do you like this reward, by asking how much do you want it, how much will you work for it, how much will you consume of it, on these various ways. We were asking about liking in a little bit different way. We were asking about liking for sweetness rewards the way human parents for eons have asked their newborn babies, by basically giving them a little taste and seeing what they do with it. Do they seem to like it? Do they spit it out and gape? Sweetness versus bitterness gets facial responses even on the first day of a human infant's life. Sweetness, lip licking and relaxed face. Bitterness, gapes and head shakes and such. Orangutans, chimpanzees, gorillas, if you give them these tastes, they give you the same facial expressions, similar facial expressions. New World monkeys, Old World monkeys, even omnivore rats, it turns out, have facial expressions to sweetness versus bitterness that are overlapping, gapes to bitterness, lip licking to sweetness. And it's sweetness versus bitterness, but it's not really sweetness versus bitterness. You could take a sweet taste, what the rats like, pair it with nausea several times if it's a new sweet taste. If a human experiences a new positive, new delicious taste, and you get nauseous afterwards, quite often we develop a learned taste aversion, a conditioned taste aversion, the John Garcia effect. And now in the future, we find that taste disgusting, even though we liked it the first time. We'll get this. Rats will switch their facial expressions to the taste from sweet to disgust. And we can go in the opposite direction too by creating learned likes. So when we started looking at dopamine manipulations, we thought if we suppress the dopamine system, we'd suppress the liking reactions to the taste, maybe get disgust, but definitely suppress the liking reactions. We did this with drugs. We failed to suppress the liking. With my colleague, Terry Robinson at Michigan, Terry Robinson was looking at brain dopamine systems, sensitizing them with drugs, but he was also taking them out sometimes with what's called a selective dopamine lesion. It's possible to anesthetize a rat and to micro-inject a little droplet of a neurotoxin that only kills neurons that have dopamine. It's like creating an instant Parkinson's patient. And if you put this in the pathway of the dopamine fibers, you destroy the dopamine neurons, but you don't destroy any other neurons. All the rest of the neurons of the brain are absolutely normal. This is called 6-hydroxydopamine. It's a neurotoxin. And the rats become essentially, they lose all mesolimbic dopamine. We could measure it later and find that they've lost 98%. They have only 2%, 1 to 2% of dopamine left. These rats will never seek out any reward. They won't eat voluntarily. They won't reach out for good food. They won't drink voluntarily. They won't pursue drugs. They won't pursue anything. Like a person who has late Parkinson's disease, stage Parkinson's disease, they are apathetic. Anhedonia is a term that's often applied to Parkinson's disease in psychiatry textbooks and neurology textbooks. So we thought, now we'll see that they don't like anything. So we gave them the sweet taste. They had absolutely normal liking for these sweet tastes as the facial expressions. And they could learn new dislikes, these dopamine deficient rats. We could keep them healthy and in good health by essentially keeping them the same way you and I would be kept in a hospital intensive care ward with artificial nutrition and hydration. It's basically an intragastric 3 times a day liquid diet that gives all the vitamins and minerals and nutrients that we need. So they'd be kept in good health. And we could do these liking reactions and see how they responded. It was a surprise. I would say it was even a disappointment to me in the beginning because I believed dopamine was pleasure liking. Everybody believed it. But what we were seeing was that liking was still intact. And originally we thought as kind of a post hoc explanation for why it is that they would seek nothing, why it is that the dopamine drug blockade would reduce their seeking, to say, well, maybe pleasures are both liked and wanted, but maybe dopamine isn't mediating both of those. Maybe it's not mediating the liking component. Maybe it's only mediating the wanting component for those like rewards. It was a post hoc explanation around 1990. We suggested it. I thought it was possibly true, but I didn't actually, I wouldn't have bet on it at that time. A couple of years later, we started to turn on the dopamine system with electrodes that were basically reward electrodes. Rats would seek out these rewards, electrodes. They would work to turn on the electrodes. And if you turn the electrode on freely, it would motivate the rats. They would start eating 4 times, 5 times more than they normally would. The explanation often given then was that the electrode made them like the food more, so they would eat more of it. And by itself, the electrode was liked, so they would work for it. We could easily test whether the electrode was making the food more liked. They were certainly making them want to eat lots more of it. So we would turn on the electrode as they got a taste or turn it off as they were getting the taste. And we expected the liking reactions to go up if dopamine was pleasure liking. They did not. If anything, the aversive disgust reactions went up to sweetness when we turned on the electrode. It was as though they were not eating more because they liked the food more. They were eating more despite not liking the food anymore, and possibly even while finding the food a little bit more disgusting as they were eating all of this food under the electrode. Later on, we could turn on the dopamine systems with micro-injections of dopamine stimulating drugs and other ways of sensitizing the system. But the answer was always the same. We could turn on wanting. This would make them want to eat. It would make them want to pursue rewards. They would work for rewards. And gradually, psychological features of this wanting began to emerge too. It isn't just a drive of a want. It's more of brain's reaction to a percept. So for example, cues for reward become tremendously potent when the system is activated. If we just turn on the system, there isn't necessarily strong wanting, but if we turn on the system and a cue for reward pops into view, the rat intensely wants this reward and speaks out. We can all cues for reward. If we're walking down the street and we smell food, if we've just had lunch, we're not going to respond very well to that food. But if we haven't had lunch, it may suddenly make us feel hungry. Now we want to eat. Right. Or we see something else and now we want that. Cues can turn us on to turn on craving and wanting if we're in this reactive state. The dopamine system is the basic reactor to this. Now, this was wanting versus liking. It was emerging in the 1990s, and many of our colleagues at the time would have said, it's a silly question, wanting versus liking. It's a philosophical question. It's a semantic issue. It's not a scientific question. If it is a scientific question, it's not one that could be answered in animal experiments. But we were beginning to get this, picture that there was this psychological reality that could come apart. It took about 10 years before human experiments came along that started to find the same thing, but eventually they did. People would be given drugs to block their dopamine receptors at the same time they were given, say, sweet tastes or drugs like cocaine. They would still like those rewards, but they wouldn't want them so much. So gradually the field started to come around, but it took over a decade. Now, for addiction, the reason this became an addiction theory was because at the same time that my lab was focusing on dopamine psychological role and trying to get a sense of what causes liking, what causes wanting, dopamine causes wanting, my colleague, Terry Robinson, was doing drug experiments, and he was finding that drugs of abuse like cocaine or heroin or alcohol, if you take them again and again, everybody knew, and it's certainly true, what happens is you start to get tolerance to the drugs. Receptors, you get what's called receptor downregulation. Some of the receptors for the drugs go away, like dopamine receptors and other receptors, they go away. The neurons absorb them, so they're less responsive to the drug. And now there's tolerance. The drug won't have as big an effect. And if you suddenly stop taking the drug, you may have withdrawal because there's fewer receptors and now there's no more drug and there's just normal transmitter and there's fewer receptors, so you're in withdrawal. But all of this goes away if you stay off the drug for weeks to a month. Most of the tolerance goes away, the withdrawal symptoms disappear. Terry Robinson was finding a different kind of change in the brain that didn't happen in everybody, but it did happen in vulnerable individuals, and it's called neural sensitization. And what was happening was that the dopamine neurons in these systems, the first time you took the drug, they would squirt out dopamine, a certain amount. That's what the drugs do. They make the neurons squirt out dopamine. That's part of the addictive, that's the part of the reinforcing and the drug addictive action. But if you took the drug 10 times in these vulnerable individuals, on the 10th time, it would squirt out more dopamine than it did the first time, even to the same dose. This is though the drug becoming more effective. Not only was the drug eliciting more dopamine, but cues for the drug, associative Pavlovian cues, where the drug was taken, the context predictors, the setting of the drug, they could evoke this higher dopamine response too. Now, the funny thing was, if the brain dopamine system sensitized, and then you stopped giving any drugs, so you stopped for a month, stopped for 6 months, stopped for a year, and then came back to the same, this was done in rats, these experiments, come back to the same rat a year later and give it finally a drug again, the sensitization was still there. The hyperreactivity was still there. Unlike tolerance and withdrawal, sensitization doesn't go away. Now, not everybody sensitizes at street doses of drugs. You could sensitize everybody if you gave high enough doses, but at street doses, not everybody does, not even all rats do. But some are vulnerable. Through genes, individual genetic differences can make some of us vulnerable and some of us less. Previous life experiences, like stresses in life, can cross-sensitize and create a vulnerability to drug sensitization. So those who become sensitized, the notion was if dopamine mediates wanting, and if in some individuals drugs of abuse cause this neural sensitization, then you might have an individual who's an addict who becomes sensitized wanting, their wanting goes up and focused on this drug, even if their liking didn't change or even if their liking for the drug went down. You have the separation. And if it was induced, it would last. It would last a year. In a rat, that's half a lifetime, and it might last half a lifetime in a person. human experiments have been done now on sensitization. Definitely it lasts a year, even if you just take people off the street and sensitize them in the laboratory. They come back a year later, they're still sensitized. And addicts, the persistence of addiction and their hyperreactivity of addicts' brains to drug use suggests that could last half a lifetime too. The thing about
quick clarification, not to interrupt, but are you saying that you can't have sensitization and tolerance? Is that correct?
Actually, you can. You can have them coming at the same time because they're sort of in slightly different intracellular and molecular pathways, even in the same neurons.
I see.
So they're happening sort of in parallel. And in the short term, the tolerance and the withdrawal, that seems to dominate. So it's very, very visible. But in the long term, if you stop taking the drugs, they go away, those changes. But the sensitization changes, they not only don't go away, if anything, they get stronger in the first months or so of not taking the drug. What's called incubation of craving. It could be incubation of this neural sensitization change that's building up even stronger. And then it just lasts. If the brain becomes sensitized, the dopamine system, it's not always hyperactive. It is not hyperactive. It's not squirting out dopamine extra all the time. Most of the time, it looks perfectly normal. But give it the drug again, and you get this hyperreactive response. Or put drug cues suddenly around, and you can get this hyperreactive response.
Yes.
So it's sort of gated by the moment, by stimulating the moment. It's hyperreactivity, not hyperactivity that's constant there. It's again relevant to why cues are so important psychologically to normal desires, but also especially to addictive desires. Cues are potent.
It's fascinating. So would you say that this is starting to get toward a neurological profile of someone who might say they have an addictive personality? Is the type of brain that's more susceptible to neural sensitization?
It could well be that having what's called an addictive personality maps on to this vulnerability to neural sensitization. The next question would be, would it be relevant to other kinds of addictions beyond drug addiction? If it's a generalizable addictive personality. And the funny thing is, if you had asked me 10 years ago, did I think our neural dopamine sensitization story was relevant to behavioral addictions like compulsive gambling or compulsive sex pursuit or compulsive binge eating or things like that, I would have said I didn't think so 10 years ago. And the reason I would have said that was because we know through neuroscience, molecular biology studies, a little bit of the mechanisms of how drugs do sensitize this dopamine system. They make the dopamine neurons more responsive to excitatory signals coming into them because they're sprouting more, the dopamine neurons are sprouting more glutamate receptors for excitatory glutamate inputs that are coming into them. So they have a bigger dopamine response. Other changes too. So these changes could be specified. But thought drugs are doing this. Cocaine is doing this, heroin and other drugs are doing this. How is it that gambling or other things are going to do this? Well, I should have remembered that actually even Terry Robinson, my colleague here, had shown in the 90s that it is possible to sensitize rats without any drugs through things like early stress experiences that then cross-sensitize. Some individuals may be so susceptible to the induction of sensitization that life experiences that we can encounter might sensitize them. And it may be that the behavioral addictions are basically tapping into this. The reason I now believe that this might be happening, what convinced me to change my mind was really basically neuroimaging studies done by other people. I don't do neuroimaging studies, but other people who are studying gambling addiction and food addiction and things. And it isn't happening in all of these individuals, but some individuals are starting to show in fMRI studies this brain mesolimbic hyperreactivity signature to the addictive cues. So compulsive gambler may have a special hyperreactivity to gambling money cues that are larger. This hyperreactivity is a more intense brain response than that same individual's response to other kinds of reward cues that aren't gambling. Hyperreactivity focused on this. And likewise, hyperreactivity in this compulsive gambler, a more intense response than the same cues of gambling would evoke in recreational gamblers who do gamble and enjoy it, but who can take it or leave it. This is the kind of signature hyperreactivity focused on the addictive cue that drug addiction can produce. It's a sensitized response to the addictive cues. And there are studies from sex addiction, gambling addiction, and some food addiction that suggest this may be happening at least in some individuals. Then the question becomes, how many individuals? Who are they? Where does it stop? How does it map onto compulsion? And that's sort of still ongoing.
And just to go back to the like versus want distinction, I think you certainly, I think that's absolutely real. And I say that largely thanks to the people I've gotten to know in my work who have severe addictions to hard drugs, methamphetamine, heroin, prescription drugs, and stuff that's really addictive. And many times I've heard people say, I don't even like it anymore. I just can't stop. And so that's definitely what was coming to my mind when you were clarifying that distinction. And it seems just absolutely true that you don't necessarily have to like it anymore to be motivated for it. So what would a person listening right now who has their own addiction, and if we all look honestly enough, we can all probably find something that either could become an addiction or is, and how can a person apply this knowledge? How is it helpful to understand this? What can we do with it?
Well, the first thing it gives us is a better understanding of the nature of addiction. For a long time in addiction neuroscience, it was thought that it was really all about withdrawal. Withdrawal was the driving force in addiction, so you'd want to get rid of the withdrawal, and then you should be able to get rid of the addiction when you did that. But if it's sensitized wanting, it can emerge, as you say, in a person who isn't getting much pleasure from the addictive drugs anymore, and possibly even emerge in a way that confuses them. They'll have these urges, but they don't have an explanation, and they have a sincere cognitive desire to not take drugs anymore because they know what it does to them. My colleagues and I, when we talk about mesolimbic wanting, we always put wanting in quotation marks, and the reason is kind of to distinguish it from wanting as we ordinarily use the word in English language. If I've been an addict and I know it destroys my life and I don't want to take drugs, I want to not take drugs sincerely and cognitively and absolutely, that's a want in the normal sense. But this mesolimbic wanting, it has rules of its own, and it can evoke these urges. Ordinarily, this goes along with our cognitive wants for most of us, but there are moments like in addiction where these come apart. And that's, what a person has to deal with. So first, just getting insight into what's happening to them might be useful. The next thing is, unfortunately, it doesn't give us a magic bullet and a cure. Maybe eventually that will come. But there are, for some individuals, programs that help. There are some individuals who will swear by 12-step programs if they do the 12 steps every day. There are other individuals who find that not helpful at all, but may find some other help from other programs. Some people have good results with mindfulness. I don't think any of these is a magic bullet. And there are colleagues in the field who will say, well, addiction shouldn't be thought of as a brain disease because it never gets cured. It's not a disease to begin with, they might say, and it never gets cured. Even in people who can give up the drugs, they're still having to make an effort. I think that's true. So even in these even programs that help a person, it may well be that the person still lives a life that's something of a struggle in order to avoid falling back into the addiction. This may be something we have to accept too.
Yeah, and just thinking more about, again, this idea of not even liking what you want. I've also heard people state, I want this, but I don't want to want this, which I think reflects exactly what you were talking about between the conventional sense of wanting and this sort of brain being drawn to something wanting. I think many people recognize this, that their brain is fixating on the object of their addiction, and on a cognitive, self-conscious level, they don't want to be fixating on this anymore. They feel discrepant here between their kind of, again, conscious intentions and what their brain is fixated on doing.
Right. No, I think that's absolutely right. And in a sense, it kind of points again to the importance of the reality of psychological processes. Both are real psychological processes, both are conscious cognitive want and this incentive salience mesolimbic wanting system. It has psychological rules. They are predictable and understandable rules. They're not reasons, and you can't reason with it because the rules are the rules. We can understand those rules psychologically. We can pin it on these brain systems. We have to understand them both at the brain and the psychological level. Kind of interestingly, sort of in reverse, there may be a reverse of this in other forms. You know, we said anhedonia is a term that was applied for suppression of dopamine, probably inappropriately, but anhedonia is also a term that's applied to Parkinson's patients and to schizophrenia in many cases and to major depression.
Right.
And anhedonia in all these cases has meant in textbooks of psychiatry that the person finds no pleasure in life. But in the last 10 years, there's a number of psychologists and neurologists who have been probing this further and suggesting that actually in many cases, pleasure is still intact, liking is still intact in these patients. But so if you give them, say, a tasty ice cream and ask them to rate the pleasure of it, you get surprisingly normal pleasure ratings. But that ice cream isn't particularly valued by these patients, and nothing in life, the social and cultural rewards, the family rewards, the professional career rewards, they don't have value. So new terms instead of anhedonia, which would mean absence of pleasure, have been suggested like avolition, loss of volitional wanting, basically a loss of wanting but preservation, or anticipatory anhedonia versus real consumatory anhedonia. So there may be dissociations that go in other directions in these other conditions.
Interesting. And then I guess, again, I knew that with each, if I'm going to attempt to bring multiple topics in, that it'll feel like there's so much more to say about each one when we're about to move to the next one, which is feeling true right now about the addiction topic, because I do want to bring up affective valence and emotional states. But one or two more questions about addiction. So you really emphasized the way that anything that becomes associated with the object of addiction, these environmental cues, can essentially stimulate that mesolimbic wanting, right? So what value is there then in attempting to control the environment? Is that a realistic suggestion for people dealing with addictions? You really need to avoid certain environmental cues?
Well, I think trying to control the environment is a reasonable step to the extent it can be controlled. In particular, the cues like the sight, the smell, the sound, these are important, but also the setting is important. Context settings are part of the cue. They gate the effectiveness of the cue. So avoiding the settings, avoiding the situations that we've taken drugs in, that might be helpful. Now, of course, so it isn't always possible to do that. Sometimes it is, but not always. So it may be one has to kind of wrestle with it too. I had a colleague who was struggling with alcoholism successfully and was no longer drinking, and who said, well, we can go out to dinner. You can have a glass of wine and such, and that's fine. I can watch you drink it. I'll stay with my soft drink, but just don't let me smell the alcohol. That was a particularly potent cue that would be irresistible, but others could be tolerated. So it may be that there are ways, to compromise in life, to walk a middle path, that avoiding the cues that trigger us, tolerating the cues that we can resist.
Yeah, great answer. Okay. And I imagine that, addiction and emotion are not completely unrelated topics. So perhaps this isn't a hard transition to a new topic, but I want to know, so I know that one of your research interests is, the brain mechanisms of emotions and whether an emotion can be unconscious. So let's start there with that question. Can an emotion be unconscious, and what exactly does that mean?
It's a big question. I think the answer to it is yes, but what does it mean is a big issue that still needs more elucidation. I got my interest in this question really actually did start with addiction too. In the original addiction theory with Terry Robinson, we kind of presumed that wanting would be conscious. It'll always be this conscious craving. And that's how we first posed it. But we got letters from psychologists and psychiatrists, one in particular that was kind of revealing. He said, well, he's working with physicians who were addicted. There's more drug controls now on physicians than there were then. Basically, if a physician had a drug cabinet, they had access to their drug cabinet. And so it was not uncommon for some physicians to be taking drugs kind of regularly from the cabinet. And the psychologist said, well, my clients who are doing this, these physicians, they don't experience conscious, strong urges every day. They just take the drugs every day and they cope. They see their patients. But if there's a day that they can't take their drugs, then they start to feel the urge. So the urges, so are they sensitized? And if they are, where are these strong cravings and things? We began to wonder, was it possible that the sensitization urge could occur and yet not be consciously registered? That was a question. We thought, well, maybe it's possible. Maybe this is an essentially intrinsically unconscious process that can poke into consciousness. It can poke into consciousness and create conscious urges, but maybe it doesn't have to poke into consciousness to exist. Maybe it can still exist and yet not be conscious. Here at the University of Michigan, some really fantastic social psychologists were probing the question of whether emotions could exist kind of separately from conscious cognitions. And Bob Zionc, Z-A-J-O-N-C, was a social psychologist here who was really doing super work on that topic. And he had a thesis. He was actually, if we think back to the 1980s, there was a lot of reductionism then, but there was also a lot of cognitivism then in psychology. The notion that all psychological processes were cognitive, including emotions. Emotions were basically cognitive appraisals of the situation. How good is this situation for me? How threatening is this situation for me? A cognitive appraisal. That was the essence of the emotion, according to some cognitive theories of emotion. Bob Zionc said no to that. He thought the emotional reactions were sort of more immediate and independent of cognition. And so he had some clever experiments where he would subliminally induce emotional reactions in people by showing them subliminally brief, say 30 milliseconds or 10 millisecond flashes of a facial expression, happy or angry, and so brief that they couldn't be seen consciously, so brief that if you saw it, this face, and then were asked to pick it out of a lineup that you could consciously see, you couldn't pick it out. So brief, there was just no conscious cognitive recognition that you were seeing a face. Yet, if he did this, he could induce in the person kind of reactivity, where if they were then given something to rate, sort of like a new, say an ideogram from a Chinese alphabet, for example, and asked to just rate it. They don't know what it is, but they can rate it aesthetically. They're going to give, he found, higher aesthetic ratings if they'd seen the happy faces, lower aesthetic ratings if they gave them. So he could change their reaction, their affective perception, without them being aware. And his thesis was preferences need no inferences. What he meant was emotional reactions need no mediating cognitive conscious cognition in the middle to get to them. A wonderful PhD student in his lab, who's now a wonderful professor of psychology at the University of California, San Diego, Piotr Winkelmann, was looking at these unconscious emotions. And Piotr was in a seminar with me once on brain and consciousness. And we began to wonder, well, Bob Zionc is triggering he's unconsciously causing emotions, but the emotion that the person rated, that was a conscious experience. Would it ever be possible to unconsciously cause an emotional reaction that itself remained unconscious? And even if a person was describing their mood, wouldn't change their description of their mood, yet could be surfaced again in some manifest behavioral or physiological way, given the right triggering stimulus. So we did some experiments on that, and basically the answer turned out to be yes. In Piotr's hands, we could unconsciously trigger an emotion using facial subliminal primes similar to Bob Zionc. We could wipe those away with a cognitive task that the person was focusing on, not wanting to fail on. Then ask the person to rate their mood. their moods would be unchanged by the subliminal phases, and then give a person the right stimulus and reveal an affective change. The stimulus we gave them was a sweet drink that we asked them. We said, this is a new sweet drink that a beverage maker has created and they might want to sell it on the market. What do you think of it? And basically, this is a crucial thing about incentive salience. It's the reactivity of the system is always crucial. So basically what I'm going to describe, this would happen in people who had seen the faces if they were thirsty at the moment they were seeing the faces. It wouldn't happen if they weren't thirsty. This is a mesolimbic feature of incentive salience. It kind of gets at the psychological, theoretical roots of what incentive salience is. I'll mention a couple psychological names. Daluz, who invented this theory in the 1970s, basically, this notion of incentive motivation that's been operating in these ways. Basically, the subliminal phases in thirsty people would tap into them in a way that when they then experienced the drink, if they had seen the happy faces, they would rate the drink as more attractive, more desired, more liked, and that they were willing to pay, they say they were willing to pay 3 times more to have this drink than if they had seen the angry faces. Yet their mood ratings were utterly unchanged. It was changing their emotional affective reaction to the drink without changing anything that they could consciously access in the intervening time.
I see.
This was the beginning of an unconscious emotion. Now it's merely an unconscious affective reaction, valence, good or bad. It's not to say it's an emotion like sadness or anger or fear or happiness that has a qualitative property in addition to valence of being good and bad.
Right.
It's still an open question whether those kinds of qualitative emotions can be unconsciously generated. That's an open question. But we think valenced reaction, these affective reactions of good versus bad, that can be primed and remain unconscious. And just recently, in the last couple of years, Peter Winkelmann has replicated this experiment and extended it further, finding some further psychological features of it. So it seems to be real. We believe it's real.
Interesting. Okay. And so speaking of those distinct, qualitatively distinct emotions that we experience, whatever side of the valence spectrum they may be on, what I'm curious to know is how different biochemically are certain emotional states that are not all that different subjectively. And I'll give you an example. This is something, for example, Sam Harris likes to talk about. He likes to give the example of how when you really observe the experience of being anxious and of being excited, you'll find that they don't actually feel all that different physically. But there's something about the way we're evaluating the situation or the values that we're adding to everything that determine where, the valence of this experience. So that's my question to you is, how different are these states on a biochemical level?
Well, that's a question that neuroscientists want to know the answer to. And we even have a kind of preferred answer that we'd like to find. Most neuroscientists do. And the answer is that the answer that we prefer is that, well, they have very distinct neural representations, either different neurons or different neurotransmitters or different molecular events within the neurons. So ideally, all of those things, differences, so that we could then say these neurons and these cellular processes and these neurotransmitters, these are anxiety and these ones are excitement.
Something tells me this would be too convenient. That's the sense I'm getting.
Well, I think, it would be awfully darn convenient. And there are people in my colleagues who believe that it's actually the truth. But, and I believe it's partially the truth that some of these things will be distinct. But there are also many neural systems and neurons in the brain that are generating these emotional things that I think can participate in more than one. And even in more than one valence, in both anxiety and positive valence excitement. Anxiety is negatively valence. We may feel aroused, but we'd rather not be. Excitement, we might feel positively valence. We kind of like it. We would seek it again, and we're aroused. Some neural systems can flip back and forth, we think. And in fact, even dopamine which we've been talking about as positive incentive wanting, incentive salience, I think has a negative valence cousin, which is sort of a fearful salience. Incentive salience, the cue or the percept comes, this event, and we can't not look at it. The reason we have incentive salience in the term salience in the incentive is because it grabs our attention, these reward cues. If you're hungry and somebody walks in with a plate of food, it's hard not to notice it and look at it. If something else comes in that you want, it's hard not to have your attention drawn. And even if you have eye tracking experiments where you're asking people to pick things out of a field, if you bring in a reward cue, their attention goes to that involuntarily. These things are powerful salience. Well, there's a fearful salience that also involves some mesolimbic dopamine. And in that situation, it's hard not to look at something, but the something isn't attractive. It's sort of a threat. It may be perceived as a threat, and it may call forth active attempts to deal with it somehow, a fearful salience. There's a psychiatrist, Satish Kapoor, who has harnessed this idea and who has suggested that paranoia in schizophrenia, paranoia may be this dopamine-related fearful salience, where something catches the attention and it has to be woven into the explanation, which may be an illusion that the person has. So something is, you're following me, police cars are following me, other people are manipulating me, you see something, and that is involved in this conspiracy against me. It has to, because it has this compelling emotional quality. It is a threat, so you have to weave it in somehow. It's no accident that the primary drugs that are used to treat schizophrenia and paranoia are antipsychotic drugs. And what's an antipsychotic drug? Well, the traditional antipsychotic drugs are dopamine blockers, D2 receptor dopamine blockers, just like the kind Roy Wise used to use to try to get anhedonia. The newer atypical antipsychotics are serotonin receptor blockers, but they're also still dopamine receptor blockers too. So they're all dopamine receptor blockers. And Satish Kapoor has suggested that the efficacy of these drugs actually in getting fast relief from the paranoia symptoms is best correlated to the dopamine blocking effects. And in animal experiments, we can trigger fearful salience or incentive salience in the same rat by manipulations of the nucleus accumbens that involve dopamine release there. So I think that incentive salience has basically its motivational salience. It has some mechanisms and features that are always constant, but it can flip valence into incentive salience or fearful salience. And we're trying to understand what's happening in the brain when the valence flips in that way to create something that's wanted and attractive versus something that's threatening and we respond to.
Yeah, it's interesting because evolutionarily, it makes perfect sense that regardless of the valence, some things are salient and necessary to fixate upon and be motivated to deal with. So that makes perfect sense that, that this dopamine mesolimbic pathway would be involved in both sides of the valence spectrum. But what a fascinating question. What else is going on when it's pleasurable versus unpleasurable?
And I should mention some of our recent work. It comes from the other side, from the aversive side, that's suddenly becoming positive. Now, dopamine, of course, isn't the only neurotransmitter in the brain and not only even the only component of this mesolimbic circuit. CRF is famous for stress. There's the master stress signal in our brain is CRF, the initials, corticotropin releasing factor. It's the neurochemical that's released in parts of the brain like the amygdala by all kinds of nasty stressors. And it is thought to mediate the nasty stressfulness and to contribute to addiction and binge eating and to other things by basically creating a nasty state that the person eats or consumes drugs to hopefully push it down by opposing with positive pleasures. Well, we've been turning on CRF neurons. It's a new technique that we can do with genetically modified rats to just use a laser light optogenetics to just activate CRF neurons in particular brain structures. And what we're finding is that they have a remarkably dopamine-like signature psychologically. They aren't necessarily aversive, but they do potentiate desires. And of course, they do potentiate cue-triggered desires for rewards and things. It's always been famous that stress exacerbates addiction, but it's also kind of been famous, although it hasn't made it into the theoretical frameworks, that even happy stresses can potentiate addiction relapse. If you win the lottery, or suddenly develop a new romantic relationship, or get a promotion. Things. These are dangerous events for people who have binge eating, addiction, drug addiction, and other situations like this. 12-step programs recognize that all emotions can be dangerous in these situations. And CRF is activated even in rats by happy events like sugar rewards, as well as negative stresses. So it may be, again, we're finding that psychological processes, they're real. They have rules of their own, but they don't necessarily follow the rules that we necessarily thought that they did in the beginning. They might flip into those rules sometime, but they have other psychological identities, and that's what we're finding out.
Very interesting. So, okay. There was one question that you listed as a research interest, and we've spoken to it to some degree, but it's basically the question of how do brains code affective valence, which is, maybe you can tell me if you've already answered that question or if there's another way you can put it for how the brain codes affective valence.
Right. So when we ask the question, how does the brain code affective valence? We're really asking what in the brain lights up to goodness versus badness? What lights up to pleasure versus disgust or pain? What is it that's lighting up? And of course, all neuroimaging experiments, functional fMRI experiments, are meant to reveal this, what lights up. Many other techniques too. EEG is used for a similar question. Electrophysiological recording in animal studies or in some human patients where you're recording from particular neurons, their actual spike firing. They fire. Neurotransmitter release measured by various ways in the brain. All of these are codes for the event. But when we started at the beginning of this hour, we sort of raised the question, some neural events that correlate to a psychological process, to a psychological event, some of them might be causing that event. Others of them might be caused by that event, but they're consequences of the event. They are causing something else, like memories, past memories that are compared to this event, thoughts about this event, plans for what to do, not the event itself. How do we tell them apart? In fact, if a dopamine person walks into the room, somebody who's studying dopamine, they could say, hey, all positive pleasures, for the most part, turn on dopamine. If I give you a nice food reward, you're going to turn on your dopamine. Drug rewards turn on dopamine. All kinds of rewards turn on dopamine. So dopamine is coding pleasure. So dopamine could be a cause of pleasure. Well, it could be a cause of pleasure. It's just taken us many years to show with manipulations that it wasn't, that it was a consequence in the sense of the pleasure that's causing the wanting for the pleasure, but not causing the pleasure. So whatever codes comes on, but then finding the causation, what is the coding? What is the code causing? That's another step scientifically, and it requires other approaches to get an answer. It's not to say one approach is better than the other. We want all of these approaches. They're all relevant to know. It's just that if we know codes alone, that doesn't by itself tell us causes. It tells us candidates for cause, but not which of them is actually.
Right. And then, it's interesting because the way that I'm processing what you just said is you have this neurological event, which is essentially the code for pleasure, transmission of dopamine or whatever it may be. And then that is just a link in a long chain of cause and effect. And so there's both the question of what's the true origin of this subjective experience, but also there's the question of what happens next now that this neurological event has taken place, and you just reeled off a few examples there of like producing memories or compelling an action or just further chemical reactions, essentially.
Absolutely. Yes, this network of causation. This is what we're faced with in our research, and to try to actually trace what are the true causes, pathways through the network. That's the issue.
Well, let me ask you this just kind of far out question. Knowing what you know about the brain, and now that with so much experience of manipulating brains in rats, do you have any fear, or what are your visions for what is possible in terms of manipulating human brains, chemically or technologically.
I don't think we need to worry much about nefarious brain manipulations
Mm,
coming into human society. There are far more, there are easier, more efficient behavioral coercion techniques that any dictator or other system could use without having to take these steps. There is more hope, I think, for benefits, for manipulations, starting with very benign manipulations like transcranial magnetic stimulation that doesn't penetrate any physical object into the brain, but may be able to influence patterns of activity, at least with near surface structures of the brain that are near that. And it may be possible to combine that technique with others that would more selectively turn on particular ones, but not others.
mm-hmm.
In the same way that we can now, with optogenetics, lasers, and virus microinjections, turn on particular subtypes.
Mm.
That would be the hope, that there'll be beneficial manipulations that will come out. I wouldn't worry much about the horror movies.
Yeah, that's reassuring. And as a final question, I wanted to get your thoughts also on these dopamine blocking agents and on these SSRIs and essentially all the psychiatric drugs that we use. What is your assessment about current practices in terms of psychiatric drug prescription, and what's their value, and what do we need to be careful about?
Well, I'm not a clinician myself. I don't do clinical work, so I'm really not qualified to say how should they be used. I think we have to recognize that all the drugs we have available, they are clumsy tools, but they may be useful tools still. SSRIs, still, we don't understand quite how they work. Of course, they are blocking serotonin reuptake and they're boosting serotonin in the synapse. Yes, they are, but is that the mechanism by which they work? They also have all kinds of tendrils of consequences, other consequences beyond that, that might be more relevant to their beneficial therapeutic effects in raising depression, relieving depression when they do that. There's debates in the field that go back and forth. The new antidepressants, the use of ketamine, kind of a surprise that it would help, but it may be helping, and trying to understand that. The use of hallucinogenics in structured situations, can that help? We would love to have better drugs, more effective drugs, and drugs that have fewer side effects than the ones that are currently around. There are efforts to obtain this. It's very frustrating and slow. How to use the drugs that exist, that's really a clinician's question, and I would leave that.
Fair. Totally fair. Totally fair. And then I guess, even though I said that was the last question, there's interesting evidence that I've come across about the perception that people have of the likelihood that their condition will improve. People who've been diagnosed with depression or anxiety disorders, the perception about the prognosis of their condition is different based on what they believe is causing it. And that people who believe that the cause of their condition is biological, that it's whatever they believe, a chemical imbalance or some type of brain malfunction, they tend to be more pessimistic about the prognosis of their condition. And so it's an interesting question, I think, because we all want to just be accurate, but also there's the question of what narrative is more empowering. And of course, we want truth, I think, above all. But even before we know what is true, it seems that it's more of an empowering narrative to say that you psychologically have some power here, and that the origin of your condition might be more psychological in nature, and that might be something that you have greater influence over. So I guess that's my statement. And I just want to know, what's your perspective on that and the messaging that we should be giving to people?
Well, I agree it is important to give an empowering message, and it may even be necessary to give an empowering message. So stressing the psychological, the potential efficacy of psychological efforts and steps, this is very, very important. The question is whether that means that we should then diminish the notion that brain or biological causes are contributing to the condition too. We should certainly diminish the notion that having a biological cause means something is permanent and unchangeable, but that's not true. You and I are having a dynamic conversation with emotions that come and go and thoughts that come and go, and there's biological things that are happening all the time, and there's psychological processes that are influencing the next event. This issue comes up in addiction too, and many people who criticize the notion of brain disease and addiction will say, if you say addiction is a brain disease, the person may feel that they're fatalistically condemned to their addiction and stop taking steps. My own feeling is, in both addiction and depression and such, there are reasons to think that these could be legitimately brain diseases in the sense of causes that are neural, that can be understood and found, and that have these consequences that impede and impair the quality of life in a person. There are lots of physiological diseases that are like that too. And there are even some that are psychologically able to be dealt with. So for example, type 2 diabetes, sort of borderline type 2 diabetes, that can happen if we exercise and if we control our diet and reduce our weight. Often type 2 diabetes in this middle zone can be dealt with. It takes psychological steps to do that. But you say to a person, and the disease is a biological imbalance, but psychological steps, behavioral steps are very important and absolutely necessary, really, to overcome this condition. Addiction and depression may involve things like this too.
Excellent example. Yes. And I guess just one last thought I'll share. When it comes to understanding the neural correlates of the various conditions that people experience, in my own assessment, and I'm also not a clinician, so we can take what I say with a grain of salt, but I've read all the DSMs, and my assessment is that one of the things that really limits our progress in identifying distinct neurological correlates for various conditions is the variety of criteria that are listed for each condition. To me, it seems that when you look at the criteria for any of them, and any commonly diagnosed condition, there's actually significant diversity in terms of the symptomatology, to where I think like two people could be diagnosed with the same condition, but have very different neurological activity going on. So that's just a comment here at the end that I think that's what our progress will entail, is really clarifying with much more specificity the nature of these conditions. And then we'll have a chance at identifying them neurologically, or maybe even starting from the neurological, because that's at least more quantifiable, more objective in terms of what you can diagnose. So anyway, I just wanted to share that comment at the end.
Well, I'm sure you're right. I think we don't fully understand or appreciate the potential diversity of what we call a condition, but actually could be a number of very different conditions. The current DSM doesn't even use the phrase addiction anymore. It says substance abuse, but two people could present with substance abuse, and one of them might be sensitized and have this compulsive wanting. Another might be driven more by drug withdrawal and things of that sort, and hedonic self-medication, but not be sensitized. Entirely different psychologically, entirely different neurally in the sense of what's really driving their compulsive drug use, yet presenting with what seems to be similar symptoms.
Exactly. Thank you for helping me fill out that point and tying it back to everything that we talked about. That was perfect. So what a thought-provoking conversation this has been. I think I'll listen to this back multiple times and continue to digest what you've shared with me.
Well, thank you, Nick. I've enjoyed our conversation, and it's been great to talk about these ideas. And good luck with the future podcasts.
Thank you so much. And I'll just say thanks as well to everyone who's still listening, our audience here. I appreciate your stamina to listen all the way through. I didn't even mention in the beginning, I don't think, that Dr. Berridge is currently ranked within the top 10 most influential psychologists alive today. So I hope you've seen why. It's certainly clear to me why that is. You just have an incredible ability to articulate complex, information and knowledge. And thank you for making it accessible. And again, thank you everyone for listening. And Dr. Berridge, I hope we can stay connected.
I hope so too, Nick.
Okay.
Thanks again. It's been great. Bye-bye. Okay.
Bye.
If you like this video and you want to see more, please subscribe.